Hi, my name is Vanessa Guzman, and today we'll be reviewing logarithmic equations, variable in the argument. These are basically equations that involve us working with the property of log. To review logarithms, we should be familiar with the definition. It is defined as a power to which a base must be raised to produce a wanted number. Here we see a basic logarithmic equation. Log base a of x is equal to y. We should know that a is the base, x is the argument, and y is the exponent. It is important to memorize these variables. For all positive numbers a not equaling 1 and all positive numbers x, log base a of x equals y means the same as a to the power of y equals x. We see here that in the logarithmic equation, the base a is the same base in the exponential equation. Log of x is the exponent to which a must be raised to get x. Log is the inverse of an exponential equation. We can rearrange the values. This is why we can convert logarithmic equations into exponential equations and vice versa. Here are the common types of logarithms we'll be using. We have a base a log. These are logs of different bases. The base can be any positive real number. To continue, we also have the basic log, or known as the invisible base. It could be annotated with a 10 as a base or without. Whenever you just see log, note it is log base 10. Lastly, we have a natural log, which can be noted as log e or ln. This log has the base of Euler's number. One of the properties of logarithms we will be using is the product rule. To summarize, whenever a log has two arguments that are being multiplied to each other, the logarithm can be split up into two logarithms being added. These two logarithms will have one of the arguments. The quotient rule allows a logarithm of two arguments being divided can be split up into two logarithms that will be subtracted. Like the product rule, each logarithm will have one argument. The power rule can be used when an argument in a log has an exponent. The exponent can instead be multiplied to the log base in argument. So you could easily push an exponent of an argument to the front. Here is our first example. We have to solve the equation below. In order to solve for x, which is the argument, we have to simplify each side. Since all the logs have no base present, we know that it is log base 10 for all of them. We see here that some logarithms are being multiplied too. We could use the product rule, which states that any log that is being multiplied to can be converted to a log with an argument with an exponent and vice versa. So we could simplify these logarithms by using the product rule. 3 times log base 10 of 2 will become log base 10 of 2 to the power of 3. That will become log base 10 of 8 plus log base 10 of 3. That will equal to log base 10 of x plus log base 10 of 2 to the power of 2, which is simply known as log base 10 of 4. Now that we had that covered, we could further simplify by using the product rule. The product rule will allow us to have any two logarithms that are being added to each other and convert them to one logarithm with two arguments being multiplied to one another. Log base 10 8 plus log base 10 of 3 will become log base 10 of 8 times 3, which is simply 24. That'd be equal to log base 10 of 4x, since we'll be multiplying these two arguments. Using the equality rule, we know that 24 is equal to x. We could also think it as the two logarithms cancel out. So by knowing this, we know that x is equal to 6. Is equal to. Here you go. Our second example follows the same strategy. We had to simplify all the logarithms to solve for x. Here, you can note that all the bases are 3. But it's always important to look at the bases. Again, we'll be using the power rule to simplify these two logarithms. So 2 times log base 3 of 2 will become log base 3 of 2 to the power of 2, which is 4. Let's complete the side. And that would be equal to 2 times log base 3 of 4 would become log base 3 of 4 to the power of 2, which is 16, minus log base 3 of 2. Now, we could note that all the logarithms are being subtracted to one another. We could use the quotient rule. The quotient rule will allow us to convert any logarithms that are subtracting to one another be converted to a logarithm with the 2 arguments dividing each other. Log base 3 of 8x minus log base 3 of 4 would become log base 3 of 8x divided by 4, which will be equal to log base 3 of 16 divided by 2. That would simply be log base 3 of 2x is equal to log base 3 of 8. Once again, using the equality rule, we know that 2x is equal to 8, or simply x is equal to 4. Thank you for listening to my presentation, and this concludes the lesson.